Hi, and welcome to this deeper dive on Azure Databricks. In this video, we're going to talk about streaming analytics for your big data applications. Azure Databricks is a fast, easy, and collaborative Apache Spark-based analytics platform optimized for Azure. Azure Databricks drives innovation and increases productivity. It brings in teams together in collaborative workspaces on a secure, trusted cloud, and enables you to scale without limits. Designed in collaboration with the founders of Apache Spark, Azure Databricks combines the best of Databricks and Azure to help customers accelerate innovation with one-click setup, streamlined workflows, and an interactive workspace that enables collaboration between data scientists, data engineers, and business analysts. As an Azure service, customers automatically benefit from native integration with other Azure services, such as Power BI, Azure SQL Data Warehouse, Cosmos DB, as well as from the enterprise-grade Azure security, including Active Directory integration, compliance, and enterprise-grade SLAs. For this video, let's check out how we can leverage streaming data to perform analytical and computational tasks that would otherwise have high complexity without the power of Azure Databricks structured streaming. Let's talk a little bit about the complexities in streaming data. There's complex data with diverse data formats. You could have complex workloads combining streaming with interactive queries, and complex systems with diverse storage systems. Databricks' structured streaming allows you to do stream processing on Spark SQL engine. It's fast, it's scalable, and it's fault tolerant. You have the rich unified high-level APIs to deal with complex data and complex workloads, like data frames and data sets in Spark SQL. You have the rich ecosystem of data sources that integrate with many storage systems. All right, so here we are at the Azure Databricks home screen. Here we have some great documentation if you're new to Databricks to jump off getting started learning how to use the Scala, Python, R, or SQL APIs, as well as looking at what's recent in the Apache world. For our purposes today, let's jump over to a streaming dashboard where we might be a data scientist and we want to connect some historical data to some streaming data. Maybe that data is coming from a Kafka source. So let's go in and check out how that might be done. As you can see here, I'm connected to a database. We can say this database is our historical data, and it's just some ambiguous data about a maybe like a store. You can see there's some products here and some categories and etc. And we'll see that we have this product ID here because if we display what's inside our Kafka stream that we've connected up to, you can see that we have our product ID, the time that it's coming in at, and some other streaming related information. So what might be useful for us is to do some transformations on the data. Maybe we want to join it, right? The Kafka data, let's join that over to the products data with a join. We can do some aggregations with a group by, right? We can use a count, and then we can sort, which is great because it allows us to do all of the declarative transformations. It allows us to do all of the declarative functionality that we like from our Spark SQL, we like from using our Python or Scala if we would like to, but we get to do it on streaming data. So as you can see here, we have a map here. On the legend on the right, you can see that we have these updating buckets for the streaming information coming into the chart. So you can see that it looks like the US and Canada are getting the most hits to what this is like a fictitious website. You can see that we have some fringe action happening over here in West Europe. But the main focus here is that we can visualize the streaming data coming in. And if we wanted to take a look at some plot options, If we didn't want to look at this in a map, but we wanted to look at it in, say, a bar chart or a pie chart, we can do that here. So this is cool, but the next thing you might ask yourself is, with this streaming information, am I able to serve it to a machine learning model and allow it to score and then stream the information to a different location? So let's jump over to this new tab and take a look at just this. What we're going to do is load a machine learning model that we've saved. We're going to score some streaming data coming in. It's on reviews of products. And then you can see that we can actually query the stream after we've scored that information. So the first thing that I'm going to do is define a schema that I want my stream to be of. As you can see, we have our ratings, our reviews, the time, title, and user. So there's some standard review data. Let's load in the model under our variable of model. And now we can create an input stream data frame with our read stream option right here. Let's load that into our notebook, and then we'll score down here with our input stream scored by our loaded model into a new variable called scored stream. Next, what we have to do is sync the scored data. What this will do is create a stream at which we can query with the name of stream. So if I wanted to come down here and query stream, you can see I can just use SQL with select ratings, label, prediction, probability, and review, outputs that I get from my machine learning model from that stream above, and we can order by review. So there we go. We can see how we can use transformations, how we can aggregate and join streaming data to our existing static or even batch data if we wanted to, as well as score streaming data coming into a notebook live and then querying that stream after we've scored it. So what makes structured streaming so awesome? Structured streaming makes working with streaming data accessible and easy to develop on because it's built on Spark SQL, which means the computations you use for batch and static data are the same computations you'll write for your structured streaming data pipelines. You get to work with high-level APIs, which means you get all of the value from data frames and data sets, so you can work with complex data types. It also means you can transform, aggregate, and join the streaming data sets with historical data sets. And a personal favorite of mine, you can apply machine learning models to score data and stream the data out. All of this on the fast, easy, and collaborative Azure Databricks platform. Thanks for watching.